All right, guys. So hello and welcome to today's webinar. My name is Sasha Blumenfeld, and I'm the marketing manager here at Chartio. I'm very happy to be talking with today's two great guests. We have John Hammock, who is an evangelist at Treasure Data. John evangelizes Treasure Data and FluentD to their worldwide developer community. Treasure Data is a cloud service that includes data collection, data storage, and data analytics in an end-to-end managed system. We also have our very own AJ Welch. He's a data engineer here at Chartio and is an expert in helping clients build data warehousing and BI solutions to improve their analytic capabilities at Chartio. Chartio is a powerful cloud business intelligence platform that allows everyone in an organization, regardless of technical level, to gather, analyze, and share data with the rest of their company. A few housekeeping tips before we get started. The webinar will be recorded, and we will be sending out slides and the recording after the webinar. Throughout our conversation, please feel free to ask questions in the chat box to your right, or ask them on Twitter using the hashtag ChartioandTD, and we will answer them at the end of the presentation. Without further ado, I would like to introduce to you our first presenter today, John Hammock.
Hello, everyone. I'm John Hammock here. I'm a developer evangelist for Treasure Data, and we're gonna get started with this thing. So, great. So we're going to actually start off with a question. Why would you want to why would you want to build your own event pipeline? Sorry for the little technical glitch there. Well, there's actually a number of reasons why you might want to do this. You're probably somebody who sees analytics as a strategic differentiator. And maybe the first reason you want to build your own event pipeline is to improve your product. So let's suppose that you're making a smartphone game, and in the new release, you just introduced a referral feature to drive growth. By inviting your friends to the mobile app, your user requires free virtual money that can be used to make in-app purchases. Your product manager perhaps is interested in tracking usage for this new feature. That's easy enough. Your mobile engineer goes ahead and adds a new event with a field called number of referrals. The idea here would be to look at the distribution of referral counts and identify power referrers because they can be your growth driver. Also, by summing up all of our referral counts, you can calculate your outflow of your virtual economy, making sure that you are not giving away too much for free. Another reason you might want to build your own event pipeline and track your own events is to improve marketing. In the case where you're a growth manager for a startup and you want to better understand which campaigns and web pages are performing better perhaps, so your web developer will add an event to each page with a field called Site A or Site B respectively to gauge test points for your click-through path, understand your click-through rate when combined with a timestamp, or, for example, the result of your split tests. And yet another reason you might want to build your own event pipeline and track and analyze your own events is to improve operations. So let's say you're an energy company. You're running several windmill generators and you want to maximize cost effectiveness and or revenues by understanding your energy generation throughput. You can add an event to log and record your number of rotations and map the rate of rotations against time of day, month, and or seasons. Or let's say you're a hotel chain and you're running smart thermometers in all of your rooms. By collecting time-stamped event data and mapping this to weather fluctuations, energy consumption, and peak consumption times, it would be possible to optimize your energy expenditure costs by leveling the consumption around the central tendency of all your consumption hours. Maybe you can think of more examples where adding events to your system might be useful. So let's continue actually with another question, and those are what would be the key components of a data analytics pipeline? Well, the first thing is going to be your source. This is the place your data originate from. It could be an Internet of Things device, for example, a thermostat, maybe a connected car, a windmill, a television, even a refrigerator. It could be a web application, it could be a server log, for example, a web auditing log, maybe a security log, maybe a load balancing log. The thing that these sources all have in common is that they are sending events when the applications or software reaches a certain state. Say, it fires a certain line of code or it performs a given task. It's important to model your software applications against use cases, or the other way around. Model use cases against your software application and carefully select those use cases, steps, operations, or states you want to measure, quantify, track usage of, and or gain insights from. Well, the next part of your data analytics pipeline is going to be ingestion. And ingestion is the process of getting your data from your data source into your system for analytics. And there are numerous ways to ingest data. You can ingest them through events, for example, by using Treasure Data's SDK, something like FluentD, for example, which is the unified logging layer, or FluentBit, which is a logging layer for embedded devices. You can get data from your data source, of course, by uploading the files directly into your system. For example, maybe you're uploading a file to an S3 bucket or uploading into a system like Treasure Data. You can get data into your system by running copy commands. For example, copying tables into Amazon Redshift. You can also ingest data by using any number of streaming data collectors, for example, Kafka, or via bulk upload using something like mbulk. The next part of your data analytics pipeline is going to be your cleanup process. And this is a process of getting your data into a state in which analysis can actually take place. This may involve removing dirty data, may involve removing certain anomalies, certain data noise, for example, based on perhaps a statistical estimator. The next component of your data analytics pipeline is going to be enrichment. And this is the process of querying your cleaned up data into formats to test hypotheses, show correlations, or set it up for visualization. Of course, you can also enrich your data for longer-term storage for more complex analyses later on, among other things. And last but not least, your data analytics pipeline is going to have visualization. This is maybe the hardest task of all because it can be seen as the least intuitive, depending on your perspective. In this step, we visually summarize our data into a graphic object that illustrates our point intuitively to our intended audience. So let's talk about what kind of data sources there might be. Well, web logs are, for example, one. We've all seen the standard web log, a log of 404s, for example, of paths, which referred our users. Anyone who's ever used Google Analytics is probably going to understand a thing or two about web logs, as is anyone who's ever, for example, configured an Apache server or a web server of any kind. So web log is basically tracking, for example, web use and web transactions. Another one is going to be server logs. For example, tailing our server logs to understand transactions, port access, and so forth. Another data source might be, for example, IoT events, so Internet of Things device. So, for example, if you have a thermometer that's sending an event over the wire when, for example, a value, perhaps a temperature or a humidity index, reaches over a certain threshold. Another data source could be, for example, point-of-sale machines. And one example we have here might be an automated toll drive-through, which is logging events along with cost data, or something like an iBeacon. And one of the data sources we don't actually talk about here is other databases. So we need to be able to get data that's been aggregated into other databases. And let's look a little bit at these. So in the NoSQL database, and mind you, we also have SQL databases that we have to account for as well, but in the NoSQL world, there are a few things here. Our document store databases, as an example, we have CouchDB or MongoDB. These could be basically, in a broad sense, they're a collection of key value connections, but they're basically a collection of what are known as documents, which are arbitrary length key value strings which store values. Advantage of these for storing data might be that they're basically incomplete data tolerance. So with the sharding and replication strategy, I can have some data over here and some other data over there. One of the weaknesses, though, is there is no standard query syntax. Query performance isn't a weakness as such when you're accessing the databases directly, but over a period of time, they can slow down when you have many nodes working together. In the key value area, then, we have stuff like Amazon Simple DB, Redis, or React, if you've ever heard of these. These work as a collection of key value pairs. Very fast lookups. They're excellent, for example, for storing application states, for example. However, a weakness is that the stored data has no schema. An elaboration on your key value databases are going to be your columnar NoSQL databases, H-based Cassandra. They're based on column families, and they look a lot like key value databases, except they're in a table, and except for time series data, there's a time column added to them. Again, very fast lookups. They tend to have very low-level APIs to access. So you're seeing some of the challenges here with getting data from and putting data into these different data stores. You have to have different syntax. You have to understand different APIs and different schemas. In our last category, we have the graph NoSQL databases. So if anyone's ever seen, for example, the Facebook Friends graph, this is basically a database that shows connections between nodes. And those are just the NoSQL database types. We also have SQL database types as well. This brings into a number of challenges. For example, how do I actually build my pipeline? I need to account for data that's coming in. I need to account for data that's been historically stored in other data stores. I need to be able to export data into these other stores. Another challenge is going to be how many resources do I need to use to maintain this thing. Since it's kind of a variable question, it becomes a very complicated answer. And even more so are some of the challenges we kind of talked about, right? We talked about data from multiple sources. We talked about data that's in multiple formats, getting it into, getting it out of those formats. Consider another thing like type conversion issues. If I, for example, move data from MySQL into Redshift, well, char and varchar in those respective database means two different things, as does integer types. For example, MySQL has integer types for 1, 2, 3, 4, and 8 bytes, where Redshift only has them for 2, 4, and 8 bytes. So you're going to spend a lot of time trying to figure out all of these changes in schema, in format, and so forth. So how do you solve this problem? Well, there's the false solution. You can create a data analytics pipeline based on randomly copying tables here and forth and making a point-to-point integration, manually spinning up servers, so forth, and basically spending a lot of time. But there's an easier way, and basically here it is. Treasure data. Why not use a one-stop solution that's going to account for any number of third-party data sources and third-party data destinations and visualization tools? Why get stuck on piecing together a point-to-point integration of fixed pieces of your data plumbing when you can use treasure data as a flexible data hose? So treasure data is a universal data collector and storage that can easily collect and store data from any source and integrate it seamlessly with Chartio to produce stunning visualizations. And our schema flexibility and ease of use is why so many of our customers have chosen treasure data and continually working and expanding our use cases and our usage with them. So who are we? Well, we are a cloud-based data analytics pipeline. We're based in Silicon Valley and in Tokyo, Japan. We started with FluentD, which is the open source unified logging layer, and also mbulk, which is a popular free and open source bulk upload tool. In terms of our data storage and data transition, we're processing Twitter's load times 1,000 events per second. So that's more than 45 billion events per day. With that, I'd like to thank you, and I'd like to pass it off to AJ.
Great. Thank you so much, John. We are going to now give it away to AJ. AJ, can you hear us? Oh. Okay, give us 1 second. There seems to be some audio issues. Just hold on there for a second.
Okay. So can everyone hear me? I don't know, John, can you still hear me?
Absolutely.
Awesome. Perfect. Sorry about that, everyone. So my name's AJ. I'm a data engineer here at Chartio. And today we're going to talk a little bit about the other end of the pipeline, namely data destination. So John did a great job of talking about all the different data sources and what you need to kind of bring those into one unified model. And we're going to talk about how you can plug that into Chartio and start to visualize the output of your data pipeline. So first of all, what is Chartio? Chartio is a cloud business intelligence tool. It's built for every device and every user. The main goal with Chartio is to empower anyone in the business to visualize their data. So this means not just non-technical users, not just technical users, excuse me, but also non-technical and business users as well. So these are just some of the customers that have used Chartio to accomplish this at their company. So you can see a lot of the smartest companies, a lot of the companies that you use every single day through the web and through your mobile device use Chartio to make critical decisions in real time. We also have some more extended case studies that you can find on our site. So if you go to chartio.com/customers, for each one of these, you can get a detailed case study of exactly how they're implementing Chartio to drive analytics across their company. So let's spend a minute talking about modern business users. Give me 1 second here. Okay. So like I said before, Chartio is built for everyone in the company, not just the technical users. And before we kind of talk about how we accomplish this, let's first take a look at what the modern business user is doing today and kind of what sort of needs Chartio needs to address. So there's a whole bunch of different roles within a company. You have marketing, sales, product, engineering, management, data teams, support. And a lot of times, really, it's only the data team that has the technical skill to access a relational database and get the data that they need out of it. If you're just selecting data from a table, that can be simple enough, but when you want to calculate more complex reports, it gets hairy pretty quickly. Also, the usage patterns are a lot different than what we used to be, than what we're used to seeing. So there's a very frequent use of dashboards and reports to make decisions on a much more rapid basis. A lot of times, these decisions are being made on the fly, not from someone's desk, but while they're on the run with a mobile device. There's also the occasional exploration and creation of charts. So a lot of business users were used to them just consuming reports and having a data team be the one that actually built the report. More and more, we're seeing the business users actually need to do the exploration and do the report creation themselves. And all of this is because they need answers. They need answers to do their job efficiently. So what we're hinting at here is that in the old way of doing things, often you had to rely on a data person or you had to rely on Excel to get a lot of these answers. And what this sort of creates is a centralized BI bottleneck. So this is how we sort of view a lot of the legacy tools in the market today. Basically, you have a data team, they're using a BI tool and maybe a single monolithic data warehouse, and they're piping all that data into one database, and they're trying to basically put all their different workloads and pigeonhole them into one technology. Whereas if they were to sort of pair different technologies, maybe they would have got a better maybe they would have got better performance, or maybe it would have been more efficient. But really, it's less of a technological problem and more of a problem about people. So the data team, you want them to be doing some of the more advanced analyses in your companies. A lot of times today, that's data science or advanced statistics. But 80% of their time is spent answering questions from the business users who aren't able to either use the tool or who aren't able to navigate the data warehouse. So this becomes expensive to set up, expensive to maintain, and there's a delay between the business users getting the information they need and making the decisions that they need to make to be effective. So at Chartio, what we're really aiming for is distributed BI. So we want the business users to be able to access the data, whether it resides in one source or in multiple sources, and to be able to query that and explore it on their own. And this frees up your data team to do what you actually hired them for, the data science and statistics and the more advanced analyses that are actually going to be a competitive differentiator for your business. So this is just a zoom in on the distributed BI model, and it can be team specific. So the whole goal here is to get the data into your sales department's hands or get it into your marketing department's hands, and you want that data to be customized to them. You don't want them to have to go fishing around through all these different reports that aren't pertinent to them. You want them to have the data that they need for their job as quickly as possible. But this presents a problem. Once people have access to that capability of distributed BI, and there's a whole bunch of different data sources that are available to them, it becomes difficult to understand where they should actually put their data, which databases are best for them as far as querying their data. So Chartio can connect to a whole bunch of different databases, and we're going to go over a few of them here today. But mainly we focus on relational databases. So what we found is that the relational model is a very good model for exploratory analysis, especially when you want to roll out to non-technical users. So this kind of goes to what John was speaking of earlier with some of the NoSQL databases. You know, you need to be a little more technical. You need to have some lower level programming skills. So that may not be the best fit for the business user. So with the relational model and SQL, we found it's a lot easier to roll that out across your company. But even then, there's still a whole bunch of different types of relational databases. So which one is best for your business? And that's what we'll cover right now. So we've broken it out at a high level into 4 different categories of databases. So the first category that we're going to cover here is commercial. And we're going to cover these from a high level perspective. We're not going to dive too deep into the technical details. We really just want to give you an overview of what's out there and start you off on the right path to make the decision about the database that's best for you. So commercial databases. Commercial databases have historically been used for both OLTP and OLAP. So OLTP is online transaction processing, and OLAP is online analytical processing. Transaction processing is basically what you would think of as the back end of an application, the back end of a web app or the back end of a mobile app. And OLAP is traditionally what you would think of as a data warehouse. And so basically, OLTP is kind of like the front end of your data pipeline. This is sort of like the sources that John was talking about earlier, and OLAP is the back end of your data pipeline. So a lot of what you are going to be plugging Chartio into is going to be an OLAP system, and your decisions should, at least as far as where your data resides, are going to be geared towards optimizing for OLAP. The commercial databases have a broad set of features. The pros of this is that they implement most of the SQL spec. So believe it or not, SQL does actually have a specification, and the last one was in 2011. Most people are really only familiar with just about SQL 99, which is pretty old at this point. And there's a whole bunch of features in there that make analysis extremely easy compared to what you used to do. A lot of it is geared towards getting rid of redundant subqueries and giving you nice syntactic features to write those subqueries, you know, in a single line, or write them in one place with common table expressions so you don't have to keep using that logic over and over again. So if you're looking at an OLAP system, you definitely want to have at least a good portion of the features that are available in SQL 2011, and most of the commercial databases have that covered, largely because they play a big part in writing the spec. They also have a lot of proprietary features, so those features can be nice, but again, you have to remember that they're proprietary. The cons here is that they often get categorized as bloatware. So these databases have been around for a long time. We're talking 30 years for some of them, and there's a lot of features in there, but they also are huge binaries to install, and as you can see in the next bullet point, they require a lot of expertise to manage. So you get a lot of functionality. Sorry, the slides weren't advancing there. Okay, we're good. We're on the commercial side now. You get a lot of functionality, but it requires expertise to manage. Finally, the last thing is these tend to be expensive. So you do have to license them. These companies are public companies. They have revenue numbers to hit, and these can be very expensive licenses, especially if you get them for on-premise licenses. So the next category here is open source. The open source databases, there's really two main ones, and then there's a lot of derivatives based off these databases. So we have Postgres and MySQL. Postgres historically has been looked at as more of a full-featured database similar to Oracle. It has strong OLTP and OLAP capabilities. MySQL tends to be known as a database that's really good as a transactional processing database. So the really good is the back end of a web app or a mobile app. And historically, there's been benchmarks that shows that it's faster than Postgres, although nowadays they've kind of converged on that front. Postgres tends to have more derivatives, so there's a lot of databases out there that are based off of Postgres. Amazon Redshift, which John spoke about earlier, is based off of Postgres. So if you build on top of Postgres, sometimes it's easier to move your reports and analyses to a different database if need be. One interesting point is Greenplum, which was a proprietary database, data warehousing system made by Pivotal, which is a part of EMC, was just open source yesterday. So we just got a brand new database into the market that's completely open source and based off of Postgres. One thing to mention about MySQL is that although it's really good at transaction processing, at least what we've seen amongst our customers is that it can be difficult when it comes to analytics. So MySQL doesn't have some of those features that we were talking about that are in the SQL 2011 spec, and some of the features that aren't in the spec, but other databases like Oracle and Postgres have. So these are things like C2Es, which allow you to write your subqueries in one place and reuse them over again, so you don't have to write your logic multiple times. Window functions, which allow you to do things like rolling computations, set returning functions, which are really good for generating time series data, and then a whole bunch of rich data types. Postgres specifically has an extensible data type system, so you can add your own data types that comes with some interesting data types out of the box, like IP ranges, stuff like that. But both of these, again, they're open source and they require expertise to manage. They're not quite bloatware the same way that the commercial systems are, although there's a lot in there. But I wouldn't say that it takes any less expertise to manage. If you want to get the most out of these, you need to know, you need to cover a decent amount of ground as far as knowledge. So the third category here is cloud OLTP. So over the past 5 years, there's been a lot of cloud vendors that have come in offering hosted database services. And in the beginning, they focused mainly on transaction processing. So we've had Amazon RDS for a while now. And Amazon RDS actually has the most comprehensive offering as far as which database they'll host and manage for you. So they'll host Oracle and SQL Server as far as the commercial ones go. They'll host both Postgres and MySQL. Last year, they announced Aurora, which is their own distribution of MySQL that's supposed to be very geared towards performance. And then this year, they just announced that they are going to host MariaDB, which is another open source fork of MySQL. MySQL is owned by Oracle nowadays. There's Heroku Postgres. So they focus specifically on Postgres. The nice feature with Heroku Postgres is that they actually let you install some of the extensions. So it's a little more flexible in what you can do with Heroku Postgres compared to some of these other managed services. Google Cloud SQL, which is based on MySQL, and Microsoft Azure SQL database, which is obviously based on SQL Server. So the real advantage with all of these is that they're fully managed. They tend to be used as the back end of web apps and mobile apps, but if you don't have a whole bunch of data, there's really no reason you can't use these for analytical processing as well. Especially if you get the open source, hosted services like Postgres, MySQL, probably MariaDB. They tend to be very cost effective. So they're super easy to set up, and they don't cost that much to get started. A lot of these services even have free tiers. The only thing is that because it's a managed service, you may have limited advanced functionality. So you don't get access to the VM, you don't get access to the operating system, you can't SSH into the box and customize the way the database is set up. Sometimes they do give you an interface to customize the config files, although they limit what you can actually customize. And like I said, Heroku Postgres actually allows you to use some of the non-standard extensions from Postgres. But for the most part, you're going to lose some of the more advanced functionality. And what you're getting there as a trade-off is the ease of use. So finally, we have the cloud OLAP systems. So these are systems that are really geared towards data warehousing and analytics. And these tend to be some of the most popular data sources, Redshift specifically, that get connected to Chartio. And it's mainly because these systems are meant to deal with a lot of data, and they're specifically tuned for data warehousing workloads. So we've got AWS Redshift, which is a Postgres derivative. It's a derivative of an old version of Postgres, and it's fully managed by AWS. We have IBM DB, which is sort of a combination of DB2 and another data warehousing system that IBM owns called Netezza. And again, this is a fully managed solution from IBM. And then we have HP Vertica, which is another Postgres derivative. And that has, I believe Vertica actually has on-premise and a cloud version of it now. All of these systems, mainly what they share in common is that they have what's called an MPP architecture, so massively parallel processing. And that word has become a bit of a generalization nowadays. There's a lot of technologies that sort of fall under that umbrella. But the big ones are columnar storage and parallel processing. So I believe John spoke a little bit about columnar storage earlier. It basically optimizes how much data you actually have to read off disk in order to process the query. And then parallel processing, these are clustered systems. So you're not just getting one server, you're getting a whole bunch of servers, and it's going to use as much processing power as it can from all of the servers to process any particular query. And that's important when you're dealing with large data sets. The main trade-off that you make here is concurrency. So these are systems that aren't meant for transaction processing. You can't really put them at the back end of a web app and send a whole bunch of traffic at them. They're really meant for interactive batch processing. So they're really meant more for analysts and business folks to be sitting there and sending off queries to them, either through a query tool like Chartio or through dashboards that just consuming. But you are going to have to manage that concurrency. A lot of them provide query queues, so Redshift has a very robust query queue that lets you manage this concurrency, and you can have different settings, different memory settings, different CPU settings, different priorities for different types of queries and different users. But again, it's something you have to kind of be aware of. Beyond that, it's a fully managed solution. You don't have to actually manage any of the replication or high availability or backup. That's all managed for you. And there's many analytical functions and features. So again, we talked about the SQL 2011 spec and the analysis features that it has in there. A lot of these databases are going to have a good portion of that. Really, I can't stress enough how important CTEs and window functions are when you want to get into more advanced analytics inside of a relational database, and most of these databases have that. In addition to that, they also have started adding features for data science and machine learning. So AWS just announced user-defined functions for Redshift, and you can define those functions in Python. So that gives you access to the whole entire Python data science ecosystem. So you can use things like pandas, NumPy, SciPy, and you can use them all within Redshift, within the cluster, so that you can run those algorithms where the data rests. You don't have to export the data out of the cluster and then put it into R or Python and do your advanced statistics there. You can do it all on the cluster. DashDB and Vertica both have very similar things, I believe. So DashDB takes a lot of its analytic functionality from Netezza, and then Vertica, I know it has UDF capabilities. I'm not 100% sure how much it has on the statistics and data science side, but it's extensible and it's conceivable that that functionality could be there. So again, just to recap, we had our commercial systems, we had our open source systems, we had our OLTP systems, cloud OLTP systems, and our cloud OLAP systems. All of those you can connect to Chartio today, but again, Chartio is really geared towards analysis, and you're going to want to look towards the OLAP systems and try and optimize for those if you can. If you have the budget and expertise to run an open source or commercial system on premise or on an EC2 instance or a VM in the cloud, and you want to be able to really customize the way your database is set up and you want to tune that for the best performance possible, then you can go with one of those commercial open source systems and manage it yourself. Or you can go for something that's a little more pared down, but may not trade off performance and may just trade off features, and it's going to be fully managed for you in a cloud OLTP system or a cloud OLAP system. So the last thing I want to mention here is Chartio has a free trial. If you have any of those systems up and running today, or if you need help getting any of them up and running, feel free to reach out to us, set up a free trial, and you'll be started in no time. Thank you.
Great. Thank you so much, AJ and John. We definitely learned a lot there. Now it looks like we have a few questions. So I think this one is for AJ. But John, feel free to add in anything as well. Okay. The question is, what are the top 3 questions I need to ask before choosing a database for my organization?
Yeah, so I think we covered that a bit during the talk. So the first thing you have to ask is kind of what are the expertise you have, and how many resources do you have to throw at this issue? How much money do you have to throw at it? If you have the expertise and the time and the budget to invest in a commercial open source system, and you need the performance or you need the advanced functionality, then you can go with one of those. But a lot of times, especially smaller and mid-sized companies, a managed system is going to be something that's more up your alley. And you can get managed systems nowadays, like I said at the very end there with the cloud OLAP systems. Just because you have big data doesn't mean you can't use a managed system and get some really good performance out of it. So you can go with something like AWS Redshift or IBM DashDB, and you'll be just fine.
Of course, treasure data as well. We can be this managed storage system for you. One of the questions I think you might want to consider is how much latency am I willing to allow? Like, do I need to be able to query my data and access it very quickly? In this case, for example, something native running directly on bare metal might be what you're into. But then again, you need to keep in mind the fact that, okay, if I'm running MongoDB on bare metal and I'm collecting my events, I'm only going to be able to store so many of those events until my database starts to really grow, and then I need to start thinking about scaling, which, for example, in the case of something like MongoDB, especially when running on bare metal, is a sharding and replication strategy. Now, as my data grows exponentially, I'm going to have to revisit that sharding and replication strategy with increasing frequency as time goes on. So something, of course, you want to think about is where this thing is going to go in the future as well.
Yeah, that's a great point. Planning for the future is always critical. So that's a great point, John.
Great. Here's our next question is, what is the best database to choose for scalability and performance? I think you might have touched on this, AJ, but if you want to go a bit more in depth.
Yeah, I mean, that one, there's no single answer to that. Again, it depends on your use case. I would go back to the previous question there. It really depends on the expertise. It depends on where you're going in the future. It depends on what you have for data. There's a lot of options out there, and I think one of the goals of this webinar was to kind of cover them in a broad, cover the broad spectrum. John, do you have any input there?
I mean, again, it really depends on what you're going to do. If you're storing something really simple with a really fast lookup, like an application state, for example, then something like a key value database may be just the way to go. However, if you're willing to store, for example, arbitrary length documents, and the information is something much more complicated, like, for example, the contents of a library or a book collection or something, where you have arbitrary length records, and maybe a document-based DB is the way to go. It really, really depends. It's almost the kind of decision you need to make specifically in each case. But it ultimately is a trade-off between, like, how much performance am I willing to sacrifice or do I require? What is the complexity of my data is another question. Is this something that I'm going to need to run and maintain on bare metal myself, or is this something that I'm willing to hand off to a managed service to do? Although when I use a managed service, I am going to sacrifice, in return for the convenience of using a managed service, I am going to sacrifice a little bit of the performance there. So there are sort of some key trade-offs you need to consider, I guess.
Thank you, John, for your input in there. This one looks like it's for you in treasure data. What are the most common data sources that treasure data works with?
Well, I can say that there's quite a few. I mean, so we import a lot of data from PostgreSQL. We're getting a lot of data from MySQL. We're having a lot of customers coming to us sort of one-off and saying, can you make a connector? I need to import data from Marketo. I need to import data from Salesforce. So we're kind of building, based on our Emble connector, we're building a lot of connectors to this third-party data sources. The list is actually fairly extensive. But those are some of the ones. Of course, Amazon Redshift, if I haven't mentioned it already. Of course, we can also accept data from S3, from REAC, as I mentioned, from FTP, MySQL and Postgres, which I said already. We also have a data connector for Jira, and that list of sort of data import connectors is growing all the time.
Okay, great, thank you. Just going down the list here. So can you also tell us, John, what's the complete list of databases that can accept data from?
Okay, well, obviously visualization tools like Chartio, that's very high on our list. AWS S3, REAC, or Redis, for example, FTP, Google Spreadsheets, CSV. We can send data out via HTTP put command, Indices, Leftronic, MongoDB, MySQL, PostgreSQL, Redshift, if I haven't mentioned it already, Salesforce.com, Tableau server, and as we sit here, the list is growing.
Okay, thank you. And this one can be for both you and AJ. Can a data source be a data destination?
It absolutely can be. So in the case of something like Google BigQuery or Amazon Redshift, it can be very expensive to respectively run, for example, in the case of Google BigQuery, excess queries on the Google BigQuery, because it's a cost per query model. In the case of Amazon Redshift, it's very expensive to keep, especially more than your basic instances up, which I think are like 25 cents a minute or what have you, as opposed to snapshots. In these instances, so treasure data can serve as an inexpensive intermediate storage, saving you both the query costs. So you can store your data and treasure data and run the queries against it there and then export it, as well as uptime. So in the case of Amazon Redshift, again, you can import your data from Redshift to treasure data, do your analytics and your queries based on our Hive and Presto engines, and then export it back into Redshift. And you don't have to keep those instances up. You can start making snapshots and saving some money that way.
Yeah, I mean, I think this is one of the benefits of a tool like Treasure Data is that it really allows you to pick the data source or data destination that's best for your needs. So, you know, we may be a data destination when it comes to analytics and, you know, dashboarding, so you may want to put it in something like a data warehouse. But for other workloads that you have in your company, you know, one of the sources that we connect to may not be the best fit because it's not going to be a source that you're, you know, connecting actual analysts to or actual marketing folks or actual salespeople. Maybe it's something that you're using for programmatic access in the back end of a web app. So, you know, you need something that's flexible enough to sort of support that kind of what they call polyglot persistence. So, you know, being able to pick the database that's best for your needs. So yeah, the line between data source and data destination can definitely be blurred.
Great, thank you guys both so much. It looks like we are running out of time, so I think we will end it there. If you guys have any more questions about how to optimize and find the right databases for your organization, you can reach out directly to John at jhammock@treasure-data.com or aj@chartio.com. And thank you guys all for staying until the end. And I look forward to seeing you guys next week at our next webinar. And just remember, I will send you all the link with the recording and the presentations. Thank you guys so much.
Thank you. Bye-bye.